So, so my name is Ryan Stables, and I'm from Birmingham City University. And the idea of this session is that we have a couple of experts from industry and academia, and we're going to have some discussion about a couple of the issues in intelligent music production, or as I'll get to in a minute, intelligent sound engineering, which is what I think we should probably call it. I'm going to start by kind of making a bit of a joke, though, because Brecht pointed this out to me earlier today, that we've been using the hashtag WIMP2 because it's the second hashtag on Workshop for Intelligent Music Production. But if you look at this on Twitter, it turns out that the top hit is WIMP2 Warrior UK, which turns out to be a cage fighter training camp. So I wonder, I wonder how many audio engineers are accidentally training to be cage fighters right now.
I'm in the wrong of them.
Yeah. Yeah. Yeah, some semantic descriptions of cage fighting. So, right, so, but in all seriousness, we have this panel. So we have, basically the way that we're going to do it is I'm going to introduce these guys, and then I have a question or two that I'm going to ask, and then I'm going to open it up so that if people out there have questions, it would be nice for you to ask them, and we'll hopefully have some kind of interactive discussion about the field, and specifically the directions that we think the field is going to go in, because I guess we have lots of people who are sort of working in areas related to intelligent sound engineering or intelligent music production, and it'd be nice to get your views on where you think the field will go in the near future, and whether there's anything specifically that you're interested in that you want to talk to these guys about. So without further ado, I'm going to introduce everybody. So the gentleman to my right is Henry Bourne. So Henry is a product manager at Calrec Audio, where his role is to conceive and design Calrec's audio products. They have a strong focus on user experience and the psychology of interaction, where essentially the job is to reduce the cognitive load required by broadcast engineers. Now, we're going to talk about this in a while, but part of the idea of putting this kind of group of people together is that people have slightly different backgrounds to each other. So Henry, I think, is going to talk briefly about his role in broadcast engineering. Today, we've had quite a lot of talks from people who are maybe working in live sound or in mixing or production. Broadcast engineering is obviously a big part of sound engineering as a field. So he's going to give some of his views specifically on how these kind of intelligent systems could be applied to the stuff that he does. So Calrec, just to give you a brief bit of background, have released a number of assistive mixing technologies. So basically they've made use of some of the algorithms that are developed in the field. They've done stuff from simple audio follows video algorithms to dialogue auto mixing, and recently they've been developing interfaces that simplify some of the more time-consuming aspects of live sport production. So to the right, to your left of Henry is Alessandro Palladini. So Alessandro is the head of audio systems at Music Group. So Music Group are a group of companies that own Behringer and Midas and TC Electronic and Clark Technic, and the list goes on. He's an audio technologist. He's a singer and a composer of around 10 years, and he has a strong interest in audio signal processing and machine learning. He has a PhD in information engineering from the University of Bologna, and he's very experienced with software development. To the left is Bruno Fazenda. So Bruno is a senior lecturer in audio technology at the University of Salford. He has a PhD from the same place in room acoustics and psychoacoustics. His expertise is in sound quality analysis and auditory perception in music production. He recently worked on a project measuring the acoustics of Stonehenge, which was covered by New Scientist and the BBC and was on the History Channel. And he's an investigator in the S3A project, which is a funded project looking at spatial audio in the home. And he's also a co-author on one of the posters here with Alex Wilson, which is an evolutionary computation approach to intelligent music production, informed by experimentally gathered domain knowledge. And then finally, to the left of Bruno is Andy Farnell. So Andy is a pioneer in procedural audio and game audio. So Andy has wrote a seminal text in the area called Designing Sound. He likes to tell me he didn't invent procedural audio, but he coined the term procedural audio. He has a degree in computer science, which is an electronic engineering from UCL. He's currently working as the head of R&D at Mogees, and he's a senior lecturer at the SAE Institute in London. So basically that's an introduction to everybody. So what I'm going to do is I'm just going to open up discussion by asking a very broad question for different people to answer relating to intelligent music production. So my question is, how can intelligent systems be incorporated into the various subfields of sound engineering, and specifically the ones that these guys kind of represent? So I think Andy is maybe going to approach this from a game audio and a procedural audio point of view. Henry obviously is going to talk about that in terms of broadcast engineering. Alessandro in live sound, and Bruno in audio perception. So I'm going to pass it over now to whoever wants to answer first. Should we start with Henry? Do you want to approach that question?
Yeah, and maybe if I could take some pictures. I've been thinking about how to start this. And I'm not sure how many people in here, or all of you might be familiar with this, so I don't want to waste your time. But I wasn't sure how many of you are familiar with broadcast and how it differs from, say, music production or front of house mixing. That's a nice picture, isn't it?
Could you please speak up a little bit?
Yes.
Use your mic.
There we go. Is that better? Okay. Right, so I'm from Calrec. This is the kind of thing that we make. Can anyone see the mouse? No, it's all going wrong. Right, thank you. Sorry. There we go.
There's your mouse.
There we go. Right. Okay, so these are kind of the products we make. So I think Brian's talk this morning, the first talk, kind of set a good kind of context for what I'm going to talk about, because this really, although it looks quite different and although it does a lot more, it's really the same 70s ideas with today's TFT displays strapped on top of it. It's much better than that in reality. It's really good. It's the best live broadcast desk out there, by the way. But it's the same kind of ideas. We're still working with the same faders, the same cuts, the same EQs, dynamics and everything. There's just a lot more of them. And I think the job of the broadcast engineers got a lot more challenging and a lot busier. A lot of our desks go into OB trucks, like this one. I don't know if anyone's been inside one of these before, but these will roll up to a venue. Say, I'm going to talk a bit about football, so we'll assume it's going to a football venue. So it rolls up and the sides expand, the truck gets a lot bigger, the furniture all folds out from the walls and the desks can fold down from the wall too, and chairs appear. It's wonderful. And it looks something like that inside. The audio guy typically gets a tiny little box in the corner. Some of the trucks have really nice, luxurious rooms. I think that is a more spacious room from the States. But the guys over here typically get little boxes like this. And so they pull up to the venue and the engineers, their assistants will go out, and talking about soccer again, they'll go and put mics around the pitch in the stadium. And it's this guy's job to mix all of that, mix the program. One of the main things about broadcast for TV is that guy who's mixing has to look at those screens all the time. That's one of the main differences. He has to match what he's doing to what's on the vision. So he's got to do a mix. People are starting now to work in immersive formats like 5.1.4. So he's got to do a mix in 5.1.4, say, to match the vision. He's also got to check that works in 5.1. He's got to check that mixes to stereo and mono, make sure that's okay for all the legacy people, basically everyone who doesn't have speakers in the ceiling. He's got to trigger sound effects. You see that screen on the left has a few big squares on there. Typically, they'll use that to trigger music or effects that go along with the vision or just background music. He's also got to set up the mix for everyone, all the talent, all the crew. He has to manage the comms, make sure everyone can hear themselves, is hearing the right sources that are coming in, the right parts of the mix, and specifically not getting bits that they're not supposed to. He has to do all that while the director is talking constantly in their ear through a different speaker. So it's like when you finish tracking and the drummer's sat at the back on the sofa just yapping onto the bass player all day. So there's about 5 or 6 different challenging jobs that guy has to do with a lot of distractions. So the kind of thing that is relevant to this conference is we're trying to come up with ways that make their lives easier, that take some of that repetitive work away from them. Using the example of the football, the main job that this person has to do, they have to build the ambience of the game. They have to make you believe that you're there when you're watching it on the TV. So they'll have a few mics in there. They'll typically have a ambisonic mic up above the crowd somewhere in the stadium, and they'll get a 5.1 or 5.14 ambience of all of that crowd, that stadium noise, maybe with the PA speakers above your head. So it feels like you're sat in the crowd, but not so close that you've got people right next to you shouting, because you don't, if you learn from what they do in movies and TV programs, it's hyper reality. It's not actually what you hear. It's better than being there. It's supposed to be. So they build this ambience of the stadium, but they also want to make it hyper real. So they want to catch all the kicks and the whistles and the shouts from on the pitch. But if you're sat at the stadium up at the top, you're not going to hear any of that. So what they do is they put mics all around the pitch. There's a lot of clever people come up with a standardised way of mixing the football. The English Premier League football, I think, is quite well regarded as being the best sound in the world for football. There's a lot of other places trying to emulate that. They've come up with this standard way of doing it, which is to put, say, 12 or 13 mics around the pitch. And it's that person's job, the main job. They spend those 90 minutes following the ball around the pitch. And when it's near a microphone or a few microphones, they'll open that fader. Then it gets kicked somewhere else, and they'll close that fader and they'll open another one. And they'll do that to try and capture all that sound that's going on the pitch while minimising all the spill. Because if they just opened all those 12 or 13 mics, you'd just get more crowd and it'd mask all the ball kicks. So it doesn't sound very challenging, but if you've tried to do it, it's really hard. I can't do it at all. I'm rubbish at it. But these guys are really good. They've been doing it a long time. But the problem is, I think one of the reasons why it's quite difficult is you've got this 2D representation of the pitch with all the microphones around it, and you have to translate it onto a one-dimensional row of faders. I don't know if you can see, it's not on this picture. Let's see, none of these. They've normally got tape stuck all the way across the surface, big camera tape, and they're drawing arrows on and labels to where the mics are around the pitch. But it's not a rectangle, and it's not easy to translate when the ball goes from the top right to the bottom left, at which fader to grab. Second nature to these guys now, but for a lot of people who can't do it, they just can't keep up with it, and they just make a mess of the sound. So one of the things we tried to do to help this, there was a lot of work done by people, AES papers on things like this in the past, was to try to build assistive tools like this, which let you position your mics around the pitch and just touch a location on that representation and have this app figure out the best combination of mics to fade up for you. Now, for the people in England, these premier sound engineers, they prefer to do it themselves still. They can do a better job. They think they can do a better job than this tool, and they're right. This is what we've done here. It doesn't sound as good as what they can do. But there are a lot of places in the world where they either they don't have the skill to do it this way, or they're just not that bothered to chase a ball around a pitch, where this can help massively. It can really help improve the output. We've been in places, by the way, where all faders are faded up, and there's a little note on the desk that says back in 5 minutes. So that shows you some of the commitment these guys have. So tools like this, the idea with them was to take that, the bulk of that, say, manual work away from them for 90 minutes so they can focus on the creative side of it, so they can actually focus on the audio and bring value to the production rather than just focusing on something that doesn't, in itself, make that much of an overall contribution. But it turns out not everyone likes to use it. It doesn't actually do what everyone wants it to do. And when you present things like this to people, they say, well, why don't you connect it up to one of those ball tracking systems that follows the ball already, so it just does it all for you, and you can completely take your hands off the desk. Which is great. And then you talk to the engineers and say, should we do this? And they go, no, not at all. It's useless. Because what they want to do is they want to fade up where the ball's going to go in a few seconds' time to catch the people shouting about what's going to happen. So they don't want to be They don't want the position of the ball to be faded up because it's behind where they actually want to be. So that's the kind of thing we're trying to do at the moment to make people's lives easier. We've gone some way towards it for some people, but it's not for everybody. There's another example on the other side of the screen, which is an ice hockey assist, which is pretty much the same thing with a different shaped picture in the background. It's quite easy to do that one. So there are places, like I say, that are using these full time, but for the people who prefer to manually get involved and tweak things, it's just not quite there for them. The other kinds of things that other sports where things like this are relevant, things like Formula 1 and MotoGP, where, I don't have any pictures of this, I should have prepared more, where the cameras, there's fast cuts and cameras to different positions on the track, and they cut in and out of the cars, and the audio has to match that. And unless you're a very quick operator and the director's queuing everything up for you, there's a load of sources on these desks, and remember how big some of these desks are. Unless you're really on the ball, you're going to miss a lot of those cues. The camera's going to cut and the audio's not going to cut with it. So some of the simple things that we do is we slave off systems like the vision switches. So when the vision switches to an appropriate camera, an appropriate fader on the desk will open, and then they'll cross-fade to some other camera when that switches again. So it's not that intelligent, really. It's just a GPO from one bit of equipment into us. It's just a switch. But in terms of what it actually does for the guy using that desk, he's now got loads more time to focus on things that actually improve the quality of the mix. There's a similar thing with dialogue auto mixers on panel discussions. If you've got 12 people on a panel, somebody starts talking, you don't want to leave all the mics open because you'll get spill and you'll just get loads of noise that's undesirable. So you try and fade people in and out, but doing it manually, you'll invariably cut people off, you'll miss the end. It just doesn't work as well. So the dialogue auto mixers are used a lot in these type of consoles. Same for you guys, I guess.
How many channels do you deal with?
Those desks have 1,000 inputs.
But in a normal show, how many of them do you use?
Sometimes all of them. I say 1,000, it's not literally 1,000 faders. You pair those up, so 6 for a 5-1. So on big 5-1 shows, you can easily use all of those.
So it's because of the surround that you pile up so many.
Yeah, and especially moving into immersive with 514. But there are also layers in the desk as well, so you go down 12 layers deep. So to try to keep anything you can do to help the guy understand where all those sources are and how you get to them that quickly, while you're doing all those other jobs like the comms and the sound effects and everything else, pretty much. I think I better leave it there for now.
Okay.
There's lots to go into.
If whoever wants to take next.
Well, I think I can follow up because we work in similar fields. We do some broadcasts, but definitely not as high profile, of course, as Calrec, because our main focus is live shows like theaters and arenas, venues, and sort of live music. So we have different challenges, but similar background, which I think differentiates the live sound with the production side of things. Everything is live. Everything must be done at the right time. There's no time to undo or redo. So being able to access, channels on a complex mix. We don't deal with thousands of channels, but hundreds of channels for big production. So and in a very small format, because those consoles can be huge, but in theaters they need to be as small as possible, and also for live music because they tour, so they need to be transportable. They need to be as light as possible. So there are a lot of challenges that forces us to squeeze the interface to a small size, and then people want to be able to access everything. So it's kind of the same type of challenges. So that's why in the live side of things, where you have a lot to fight against, like the venue, first and foremost. Every venue is different every night in a tour. And you need to, none of them are optimal very often, especially for rock productions where you play in arenas or pubs, things that were not designed for live music. So all these things, take a lot of time. So if we can come up with clever tools that can speed up at least the setup or the handling of this huge complexity, definitely will be very beneficial. But the biggest challenge, to probably answer to the question, is making them work. Because we have so much research, but really little still into products for many different reasons that we can talk about probably next. And then the user acceptance of it is just you just hit the spot. Even for just mixing a ball around the pitch, which is in the end very complex, but it sounds simple. Some countries don't want it. That's exactly what you get from the live industry. The more professional users are, the more skeptical are about clever tools, even though maybe they're gonna, save them a lot of time, down to the point that I heard people say, oh, yeah, it's great, it works, I like it, but it makes these not a professional mixing console. The reason it's professional mixing console because only I can use it. So, which like is not what everybody thinks, of course. Some sound engineers are very forward thinking, but I think it's pretty much the same in every business. You will always fight with professionals, conservative people that say, you can't do that better than me, and that's probably the art sometimes, and sometimes it's just what we need to fight against, really.
From my point of view, and I guess one of the aspects that's happening a lot in academia, and particularly at Salford, we're doing a lot of work in trying to understand what makes good sound. So we're talking about intelligent sound engineering, and at some point we will want to feed some kind of information, targets basically, for the machines to try and achieve. So this is obviously not new work. We're just looking at different aspects of it, but trying to understand what makes a good mix. At the moment, we're looking at automatic mixing, looking at trying to balance all the tracks at the same equal loudness, for instance. And we know as sound engineers that that's not the perfect definition of a good mix. So what else could we find out? What kind of correlation can we find between signal features, things that we can extract from the signal, and perception, things that we can find out from the listeners in this case? So there's a lot of work looking at that, looking at sound quality of mixes or sound quality of signals. And that might involve even the kind of the signal change, so the products themselves, how bad the loudspeakers may be, or how badly they might interact with the room, or even how the people interact with the room, because being in different positions gives you different perception of sound. We're, doing some work with Music Group, looking at how that works in live sound. And then I think more recently we've tried to expand that a little bit into, trying to somewhat teach the machine in a more rapid way, perhaps through machine learning, where you kind of feed examples. And at the moment, the work that I've been doing with Alex is really to try and bring in not only the capacity of machines to learn, but also to actually take that information directly from users in a more efficient way. So rather than doing very lengthy subjective testing where you need to test, 100, 1,000, 10,000 people and, measure a load of variables, to try and come up with better solutions, with more efficient solutions, to actually gather what it is that, that people prefer. And it's, a little bit like what was, I can't remember his name, I am sorry, but one of the presentations that was looking at equal loudness. And, the question to the user was fairly simple. Which one is loudest? Or, bring one so that it matches the loudness to the other. So giving simple questions to the users, but acquiring a lot of information in that process. And in that way, to try and inform the intelligent side of the machines more efficiently.
I guess when it comes to intelligence, we're already dealing with such a broad subject. Hidden behind the word intelligence is just an infinite amount of stuff, really. When it comes to intelligence and signals, we tend to see the same three areas of inquiry coming up again. They're structural, so they're going to be there. There is analysis, there's representation, and there's synthesis, production, some means of storing and manipulating symbolically models of sound, and ways of processing input, of looking at the signals. And we can apply intelligence to all of these different areas, and sometimes simultaneously to all three. I think we also have to unpack from the word intelligence we immediately anthropomorphize that, we personify it, and we think of human intelligence. There are many kinds of intelligence, and necessarily they're beyond our capacity to imagine. If you could think of like higher intelligences, how would say quantum computer see these sorts of problems? So what we tend to do is to map human intelligences onto domains such that they do human things. And there's this tension constantly there, isn't there? Like, do we really want it to do that? Are we trying to replace ourselves in some capacity to create mini-me's, to create automations which might be assistive, but then at some point they might be unwelcome? So the question of utility, I think, is really, really important in this subject. You know, does it really help? So to just visit a few of those, the three broad categories. For me, my personal area of research, being procedural audio, synthesis is very important to me. So I would raise research maybe like that Dave Moffat and I were talking about earlier. Dave's working on parametric estimation. How can we look at how an expert synthesist, an expert sound designer, works to understand the task model of taking a bunch of signal processing resources, oscillators, noise generators, or whatever, and combining those optimally to produce a given sound with given characteristics and control possibilities. Going completely to the other extreme, you see that intelligence in signal processing in the area of sound analysis is really advanced, but in very specific areas. So speech recognition already has this huge stack which mirrors the cognitive structures, because language is really old. We have great representations, we have phonetic alphabets, we have ways of combining phonemes into words, we have articulatory models to recreate speech at the synthetic level, and we have really good analysis methods which have been used in speech for years and years. So we're making great progress in the application of intelligence to speech. But then the talk earlier Francois was giving, you could see how those bits were missing and not connecting together in the musical domain, because it's a bit more disparate and more complex in many ways. So machine listening, you know, how does that go into other areas? I think there's some overlap between what I've been doing in some games work with things that are more pertinent to real life. I set a puzzle to my students about 10 years ago, which was if you had a fire alarm and you want something that has a sort of competitive multi-signal before triggering it. So you could have a heat detector and say, is it hot in the room? Yeah. We could have a smoke detector and say, you know, is it smoke in the room? But what if we had a microphone? Could you detect the sound of fire reliably? And it was a puzzle given, you know, in the context of we'd just done the synthesis example of making fire. And there's very strong principal components in it. There's very obvious mechanisms that can be identified. And it turns out it's not such a difficult problem. If you've got a very specific sound there, we can make a thing that can listen and get, you know, a good estimate of whether or not it's listening to the sound of fire. So where else can we take that machine listening, and is it useful to us in the arts and entertainments? Seems that lots of these things probably have interesting security applications, like, you know, speech recognition, or I know, is it Dan Stoll's doing a really interesting thing with bird sounds, like being able to identify a bird sound. So those things they're kind of fun, but there's you know, strong applications there. I think the missing area is in representation. I think when the text, really, the standard text is still De Polli and Picchiali, is representations of musical signals. There's some more specialised ones, you know, sparse representations for general sounds, but it's all at a very low level. It's just pre-analysis. We don't have many kinds of medium and high level representations for sound in the general case. We've got specialised representations for speech and musical instruments. But remember, sound is an entire human faculty. And it doesn't just break down into things that are speech and things that are music and all the other things. So I think those are the areas of inquiry to sort of in an analytical way. Personally, I was doing some stuff with Paul Weir a couple of years ago. I think I can say that now. We were working on a thief game, which is a kind of survival, a stealth game. You've got to creep around and nick stuff. And what we were working on was the NPCs, the AIs in the guards, really, and thinking about what was their level of awareness of the player. Had they seen you? Did they kind of suspect somebody was creeping around? And on the basis of that evidence, how would the music change to suggest maybe you'd been spotted, or the chase was about to be on, or the guards had given up the chase and kind of wandered off and things like that. So what we were dealing with is fairly high-level intentional models of the states of these NPCs. I think games is a very rich area for that, because the utility is kind of obvious. It's in there. We want to fake artificial intelligences within the games world, and we want those AIs to have auditory faculties and sound-making faculties. So that's a fairly obvious place to work. I guess that's all I have to say for now.
Okay, thanks very much. So what I'm going to do is I'm going to ask one more question, and then I'm going to open it up to the audience to ask a question. So I'm going to try and bring it back to this idea of future directions in intelligent sound engineering. So to me, one of the kind of future problems is the implementation side of these algorithms. So from the very start of today, it was quite clear that most of the technologies that are being developed in the field are really there for kind of beginners or musicians who've spent 20 plus years mastering an instrument, and they just want to produce some sound that, is nice to listen to. Given that, is it going to be a problem to integrate those kind of technologies into pro audio systems, where you've got a whole market of people who are professionals and maybe they know how to do this kind of stuff in the first place? So I just wondered if you guys have any opinions on whether or not it's going to be a difficult process to try and integrate the systems that are presented today by some of the talkers and the posters into the pro audio market. I don't know if he wants to.
I personally think it's going to be a big challenge, but exciting challenge. And as I mentioned before, talking to some of you, and also probably at the beginning of the talk, the technology now, the DSP and the machine learning AI is getting there really. Whereas when I first started looking at these things more than 10 years ago, it was just the beginning of it, and it was clearly not there yet. Now we are almost there. We have some impressive, things in all of the fields. What is really missing is, or not missing, but there's really little work done, is on, in my opinion, on the interface design, and because it's complex, because it's as a subject, on its own, and also because there's a huge legacy that we have to dismantle, or it's like a huge educational process to try to convince or teach people to work in a different way. Sometimes it's pointless, so we need to understand where the boundaries are. Sometimes it's just stubbornness. Where is my mute button? Where is my meter? Where is my fader? That's every time we try to push the boundaries, we do a demo to a customer. These questions always come up, and I guess it's pretty much the same for you and for other people also in studio. We're still mixing on faders, whether they are on a touchscreen or an iPad or on a physical console. So we're still stuck there. Maybe because there's a reason, there are a lot of reasons, but also because we need to re-educate sound engineers probably to work in a different way, showing them the opportunities. Now, that's not going to happen overnight for many different reasons. Probably the first is commercial. Who wants to bet on the suicide of the company? I'm going to release tomorrow a console without faders, and that's all I've got. Either I'm going to be the next iPhone, like the iPhone of mixing console, and crush everybody else, because also the opposite happens. Disruptive innovation teaches us that if you are too stubborn to keep a keyboard on a phone like BlackBerry, then you can just shut down when Apple comes in. But also, it's true the opposite. How many startups failed? Well, plenty. We don't know anything about them precisely because they failed. So as an established company, I guess we share this burden. Where should we try to dismantle ourselves and reinvent a new way of mixing? I don't know. It's a very hard question. So to me, this is probably the biggest challenge, but very exciting. How can we redefine user interfaces to allow this technology to blossom? Really.
Yeah, I think it is very similar for us. One of the things we because we're mixing for picture, like I say, you have to keep looking up at the screen above you. You have to mix based on what's on the screen. And that's really one of the drivers for keeping a lot of tactile control on the surface, and that you need to be able to feel for the controls, know where they are, reach them, know that you've got the right thing. If you're working on touchscreen faders, even if you've found the control, you can drift off, you can go the wrong way, you can end up pressing the wrong control. Or if you're just hovering, waiting for that right moment to press the button, you need to know it's right there and your arm hasn't moved and you reach the wrong thing. And I've seen some interesting research about concepts, say touchscreen faders, where there is some like haptic feedback, where you know when you're on the fader. There was some paper I read where you could feel the sound that was on that channel. Things like that were really interesting. So if anyone is looking to do some research into intelligent audio mixing based on accompanying video, would certainly be interested in that. Maybe that's a project for somebody. I think one of the other things for us as well is, in terms of the complex things that these guys are doing, if something goes wrong, they haven't got time to figure it out. If you've got if you're turning, say, one control or pressing one button, and it's doing 25 different things in the background, if something's wrong or something's clipping or it's not there anymore, you need to track down what's wrong with that. And you don't necessarily want to undo everything you've just done. So interface is kind of like the one we looked at before, where there were all the circles on the stage and you could see which is loudest, what the frequency content of those sources were. Quite often you can have something clipping in the chain, and when you're talking about high channel counts like that, being able to track down that source, maybe your output's clipping, but actually it's an input that is actually clipping, so you've got to trace that back through the console. Intelligence in diagnostics and things like that are very interesting subjects. The big desk we looked at before, when we started that, I think Calrec was more of a engineering-led company, and a lot of the hardware and feature sets were engineering-led. You've got this technology, we can use this to make this great, powerful product, and if you know how to use it, it's very powerful and very quick to use. But for people who don't know how to use it, it's overwhelming, and there's just a lot of stuff going on. So derivative products, smaller projects for lower cost, less ambitious programs and markets, we started to look at things a bit differently and think, what are these guys, what do they actually want to do with it? What type of people do they have working on these consoles? Because in a lot of places where the ambition is less, or the money is less, they don't necessarily have trained audio engineers there. Some facilities we go to, there's a person there who does the camera for a few hours, then they do the audio, then they do the cleaning, I don't know, they do everything. And they're expected to walk into the product and use it and mix a show on it, or do the camera, or do something else. So for those guys, we tried to come up with different interfaces that are more obvious, that have some kind of control intelligence. I was a bit concerned at the start of this presentation because there's a lot of people in here who are much smarter than I am, and you're doing all this intelligent processing. And I was thinking, I'm going to be talking about control, really. But actually, I think it is relevant, because all of that intelligence in control, where you're presented with all the information you need to make a decision at that point, is in a lot of instances probably more useful to one control that can completely change the sound of a source. So I think there's a huge subject that, definitely control intelligence. One of the things, sorry, am I going on too long? One of the things that broadcast is going into as well at the moment is there's a transition to IP, transport of audio and video over IP, replacing SDI routers, MADI point-to-point connections with IP networks. as part of that, there's also, I think, a big opportunity for intelligence in that network. Say if a microphone has controls within it, or the preamp or whatever is associated with it has controls, or it's associated with some video, or it knows its latency from where it is to the desk. There's all kinds of intelligence then that can come right the way through to the console to do a lot of the jobs that previously the engineer had to do. When sources, say, come in over a satellite at the moment, the audio comes in over a relatively quick, say, ISDN line, but the video can go over 2 satellite hops, and it can be seconds later than the audio. So the guy has to sit there and he dials in the right amount of delay and hope it syncs up. And on the output side, if you're routing that out of your console to somewhere where it meets up with the video later on, the video is going through some processing, some router, some graphics, it's adding a frame or 2 of delay on. And you need to delay the audio again to match up with it there. So if there's intelligence within all that control system, a lot of those tasks, which again just add to everything you have to think about, can go away and let you focus more on the content again. So I suppose, yeah, my approach is slightly different, I think, to some of you guys in that we're more about trying to take away some of the manual work and let people focus on the creativity. And then we have more scope to embrace more of the automatic creative tools, I think.
Can I just add quickly something? I think you hit another very important point. Audio is pretty much technology driven. We use buttons and rotaries and faders because that was available in the 70s, and we're still stuck to that. And one of the limitations in implementing some of the fantastic technology that research is developing is the same. We want to have a relatively cheap board, so the console doesn't cost too much. So that's another problem. Redesigning some of the hardware and software architectures is very important. It's going to be hard, and again, it's very important because the bottleneck is computational power. So, and it's not an industry that changes as quick as gaming. So we can buy a different sound card or audio card or video card every 2 years. This console has to work for 5 years, 7 years, although at least in live, this is shrinking as well towards short life cycles. Technology is also hardware technology is another challenge, I think.
I think Josh wants to come in with a point there.
Yeah, so maybe I could take this opportunity now to open up to the questions to the audience. So, Josh.
I know I'm interrupting the flow, but maybe I can kick things off. So, you guys have pointed out that intelligent production tools might make things easier, more accessible, cheaper, which are all wonderful. I'm just wondering, how do we ensure that the intelligent tools also make the audio better? Maintain the quality, because one could say if you make something available to the masses, then everyone who doesn't know how to make things sound good is going to be able to manipulate it.
Well, it already happened. Making songs was very expensive in the 90s. That's why we had good music. Now it's free. It's true. You know, even just the tape recorder in the 90s was way more and more expensive than Cubase and the sound card. So now that's why we have a lot of music, and it is what it is.
I'll try and answer that. I mean, in terms of quality, that's an aspect of human intelligence which is subjective. And there's really 3 kinds of intelligence that you can bring to bear on your music production, 3 sources of it. There is specific individual intelligence, i.e. expert intelligence. Think of expert systems. You've got somebody who's very, very good at that job and knows how to do it, and they've encoded their intelligence into some product or system or program, which kind of becomes a surrogate for them. You've got them there mixing in the room for you. You've got aggregate intelligence, which is how we train most machine learning systems. We get lots and lots and lots of subjects, and we say to them all, perform this task, and we collect the data, and we create clusters, and we'll use that to train a neural network or whatever. What we get out of that is obviously a kind of vector average of all of those collective intelligences, and we assume that there's wisdom in the crowds and that must have a good quality to it. And the third source is your intelligence, is the user's intelligence, that the system learns from what you're doing, predicts actions, predicts workflows, tries to interpolate or extrapolate from your actions. you train the system, so it's an adaptive system. So those are three quite distinct sources of potential differences in quality as to whether or not the end product is any good. I just thought I'd put that out there because I'm not really sure which one I favour. I think that the last one, I think adaptive systems which learn from their users have the greatest potential to deliver high quality because you enter into a relationship with the AI, which is your work assistant. Things which are prescriptive in that they bring somebody else's expert intelligence, they're the kind of things that raise the bar from where you start. You know, you can have Mark Ronson mix your track, and then you can do better.
Maybe we just already stated, you know, the first step is to do a fairly stupid intelligence system. Later on, as the technologies and the ideas mature, we start building smart intelligence systems.
I was avidly taking notes here because I thought you kind of pointed in something in a direction which is really key here. And what we've been finding in terms of research is that the first two levels, the expert and the aggregate, so whether it is a sound engineer or a crowd that tell us which direction they go, we've been finding that there isn't a single clear direction. So experts will mix differently. If we look at music production, we've been finding that experts will mix differently and they will cluster into different positions. And when we look at the crowds, the same thing happens. People will cluster into different directions, perhaps a little bit less guided than the experts, which then brings us to, well, I think at those two levels then presents a challenge. If we're going to create an expert machine, which of these do we follow, or how do we follow this kind of, clustering sort of trend? But then it brings us to the user, and the user really is what I think where the future directions are coming from. And we're already seeing this, we'll be seeing a lot more of this, which is personalization. So we're already getting a lot of personalized content over the web, really intelligent systems, most of them crowd-based. In audio, we will start seeing a lot more personalization. We will see, systems that will adapt to people which have hearing disabilities, for instance, in spatial audio. Not too long for that to start, coming up. And recently, we started toying with an idea of actually, personalized mixing or even personalized music composition and delivery. So there is, of course, a big challenge there, which is to learn from that individual user. We've seen talks today that try to do that. Brian was talking about that. It's rather that we learn the user space and then present that to the user as they're using whatever technology is going on. Of course, this paradigm doesn't apply in all situations. In a live sound situation, you can't please the entire crowd because, even the space will present different challenges to different areas. But I think there is a future kind of happening now, which is going towards how do we start delivering stuff which is personalized to the user. And we as a community are getting very used to that, Amazon recommendations and things like that. And it's going to be, it's going to be quick until we start, Spotify. We might start wanting to have, a particular mix of a song in a certain way because it's, sunset on a summer's day or whatever. And, that obviously will pose a challenge to, automated mixing systems. Yeah. And so
I think one of the other huge opportunities is we touched this argument is that with audio technology, we are creating hyper reality. So audio technology really started as sound reinforcement. So to overcome the limitations of the acoustical power of voice and instruments. But now it's not really anymore about that. It's way, way, way beyond that. So the current production techniques are immensely complex, especially for even live, but especially for studio mix. And so that's going to change even to the next level. It's like channel count in a console. Back in the days, 48 channels were plenty. Now, just because they go up to 160. And they still make good use of it, and they start to notice the difference. And they say, "Oh, I can't mix on a 48 console anymore. I just used to do that 5 years ago. Now I can't anymore." So I see that all these automation, all these clever tools as the next, groundbreaking, technology that will change dramatically how people mix, and they will be more creative and will create this hyper reality, and push it even further. I think that's what we've been doing already, and it's just going to be more of that, and it's going to be exciting, I think.
Okay, so I'm going to stop you there and see if anybody else has any questions that they want to talk about or any points of discussion. Anything else? Yeah, yep. In the front.
This may be a bit of a stupid comment, but there's maybe a small assumption that we're always collaborating with the music production system that we're using. Whereas a lot of music interesting breakthroughs of drug come from not collaborating with the technology and doing stuff you're not meant to do. I just wonder if you had any comments on that.
Most definitely. It's a point that I'm going to try and address in the lecture this evening is the notion that creativity is in essence a form of subversion. It's a kind of Gödel's form of problem in which you're trying to break out of the system which sets the rules. So you've got a set of axioms of things that you can do, and you want to break the system. And if you look at every innovation musically, artistically, in the history of music, in some sense, it is a big fuck you to the traditional system in which it grew up. Think of like the TB-303. It's a misuse of that system.
Or distortion. Distortion is the
A
music.
distortion, the very famous
linear amplifier.
Jimi Hendrix, I think it was Jimi Hendrix's cabinet, and he said to the engineer, don't fix it, I like the way it sounds. Leave it like that. It's broken, I know it's broken. This is what I want. So this is a real problem, computationally. When you come to designing systems that can introspect and break themselves. And I have an answer to that, but I think it's one of the most important questions to do with machine creativity, which is the subject of the lecture later. I think that cuts right to the heart of it, Chris. How can you make systems that subvert themselves?
I was, sorry for an interjection, I was overheard a comment which I thought was brilliant earlier on the way to coffee. So earlier on, we had a quote, I think it was Brian who brought that in his presentation, of a musician that had been a musician for 30 years. And then he got a new synth, and he was frustrated because he didn't know where to start. And this person making this comment on the way to coffee said, well, turn that around. If you have been a producer but not a musician for 30 years, would you expect to pick up an instrument and all of a sudden create music? Probably not. So we shouldn't presume that we can all of a sudden come here and invent the new user interfaces that are going to solve all the problems, or perhaps even, pose that critical question: are we taking creativity out of the system in that way? If everything's done automatically, where's the creativity coming from? So it's mainly a point that I'm trying to make, which follows what you're saying.
Yeah, I think if we remove creativity, we just destroy the system. There's no point really. That's why I never liked automatic mixing.
Yeah.
The buzzwords.
I think there is a level. I've got friends who are musicians. They're not sound engineers, and they often ask me to come and listen to my mix, or do you think I should put a compressor there? Frankly, I don't know, but they have this way of working which somewhat subverts the machine, subverts the system, in that they don't use the faders. They know that in the way they record in their bedroom, they always take 6 dB off, normalize everything to 100%, then take 6 dB off this, 3 dB off that, put a compressor with those settings, and they do that automatically. That's really, the first step of an automated system. If we already know the kind of basic stuff that we should be putting on things, then we can do that. And that kind of, takes away 50 or 60% of the effort in mixing. And then, of course, we can give the user the creative part. Now make it sound like a real, nice mix. And it's then in the hands of the user to show their art, to show that they can do that. So, I wouldn't say that we can't use presets, that we can't use prior knowledge, but there are places for these things in the system, of course.
The workflow, yeah.
Okay, any more questions? George?
I would like to ask quite challenging questions, because we heard a lot today about systems that perhaps help the user by learning how the system can adapt, so that the user's description of conceptual space is supported, like in Brian's talk. Franciois was talking a lot about learning how to mimic human creativity. And we talked a lot about automating certain tasks that are perhaps repetitive and taking the system to a level where we can ease these repetitive tasks or facilitate them and allow allow people to be more creative. So my question is really, how do we go a step beyond all these applications? Can we actually design systems that support creativity or perhaps encourage creativity? And my question is it a question of the interface, or do we have still lack of fundamental knowledge about human creativity in order to support systems that fuse intelligence and at the same time, rather than taking away opportunities, actually bring in new opportunities that create perhaps new ways of being creative?
I would say that we certainly lack basic knowledge obviously we certainly struggle with getting machines to create, to actually, become artists. We also lack basic knowledge that would allow us to steer a machine into creative spaces in the domain. Recently, myself and Alex, and I think you were involved in a little bit of these discussions, where we kind of tried to map features of a signal, and we see trends and we see multimodal distributions and things like that, and often you think, okay, well, this is where the trend is, everyone will try and mix for a spectral centroid of this kind. And that perhaps is an initial step into saying, well, okay, if everyone mixes towards that direction, then would a creative system subvert that and go and find a position in that space, in that dimension, which is away from the trend? Could that be called creativity? And frankly, I don't have the answer to that, perhaps a little bit. But certainly creativity in machines, we can see that, in music, it's emerging. And again, music like language is a much older language than, let's call it, sound engineering. So I would say that we're still a little bit far away from, how are we creative in the simple, generation of music or audio content from the point of view of production, let's say.
I think it must be an iterative process, like any design process in, not just creative industries. Like we look at how an orchestra has been designed over the centuries and how much it changed, to become what we think is an established concept, with automatic mix, because that's what it does. It's just, you don't need to mix an orchestra. By design, with the theater, is already mixed if you are in a good theater and you are the audience. So, if we look at electronic music and what was behind the original idea of some of the pioneers, like in particular the founder of Roland, he thought he could replicate any instrument electronically. Now, he was wrong, but he created a completely new thing, and people just subverted or used it in a different way. So that really, you can't predict it, can you? And that's what creativity is. So if you create very intelligent machines, it's not a problem. It's how we try to sell them to people, right? So if I try to sell you a piano, which is electronic, and it sounds not like a piano, I'm going to say, well, I don't like that. But probably if I market it properly or make it useful for in a different context, people will pick it up. So now, instruments probably are easier, maybe, because they are way more creative. Mixing systems are halfway between creativity and very specific technical requirements, which sometimes is down to weight. I want the console to weigh 15 kilograms. Why? Because I want to fly it. And sometimes these constraints are good because they force you to a different direction, and finally you get rid of stuff that you thought you needed to have. So to me, it's a lot about this, about the re-educational process, and it must happen all the time with mistakes and and feedback.
Yeah, I'm just enjoying the thought of how we try to sell a mixing console to a big broadcaster whose job is to subvert them, and I'm not sure for us that will go down too well. It's a good thought.
I'm going to take a question from here.
It seems to me that any automatic mixing system is doomed to extreme hostility from real producers. From personal experience as well, I'm very interested in using automatic mixing or intelligent sound engineering to entice beginners to pick it up and learn, and maybe make it very approachable to people who are just starting off. Like when you boot up Pro Tools, there are so many degrees of freedom and so many dimensions to what you're doing that it's immediately sort of scary. But if you could, and one thing we often do is we combine the high dimensional space into something small, so you can exploit that, which is kind of semantic word cloud pasting. And I feel like if I showed that to any of the professionals that I know, they would punch me. or maybe quite a hostile response. But it seems like a lot of people will be like, hey, that's really cool. So I'm wondering if we end up making two tiers of things, like a pleb tier thing and a professional tier thing.
Well, that's already the case for all of the products, isn't it? We always have that. It's all about how we present it. Like we already using automatic stuff. Like a de-esser is probably one of the first semantic, process. What is it? Is a compressor or a dynamic EQ completely automated for you? And guess what? They love it because it's that boring to set up a de-esser with a compressor or a dynamic EQ. Now you still find people that will say, oh no. The way I set it up is going to sound better, but it's like a niche now. So I think it's possible, but it's really how you present it. The industry is already organized in that way with different, type of products, I think, to accommodate that.
I'm just wondering how we can more easily onboard professionals who easily sort of scoff at this sort of stuff.
It's really interesting that, there's a
I
lot.
have a comment on that. So my favorite quote I saw on some social media forum about this whole area of research was someone who said, as a mixing engineer, I am disgusted. But as an amateur musician, I love it. And I'm
I think what you said about kind of almost training people up, that there's a lot of places where we have been asked specifically to say, can you remove all of these controls from these screens, because I don't trust the people I'm employing to not mess with them.
Yes. Yeah.
Which, who are they employing for a start? But the idea of if this person, the people are playing with them because they're interested in figuring out how they work and they want to try and improve things, but the guys don't trust them. So maybe if there were ways, like you're suggesting, where these people could get involved at maybe a higher level and try to improve and prove that they can actually improve the content that they're producing, and maybe there's useful to lead people in.
So I guess that's what we judge it by, so like, did you actually manage to improve your workflow? Or
Right.
did you speed it up? Or was it kind of like the same, just more annoying?
Yeah.
Because, for example, in the case of your set, this is number one question. In the case of your football mixing or 1,000 sliders, I feel like the 1,000 sliders setup has 1,000 ways to make mistakes, or way more. But putting it onto a 2D pad actually makes sure that I can very easily pinpoint the ball. But I feel like someone who's been doing that for decades would be like, well, I'm a professional, so I know how to fix mistakes. But having all that huge parameter space is what makes me an expert in what makes me able to have my own touch in some ways.
Well, it's control, pure control. I think you have to remember that anything connected to creativity is massively invested in, the ego is massively invested in anything to do with creativity. The sense of central control, the sense of mastery, control really comes into it. And wherever you try to take that away from someone, they're going to have a hissy.
Yeah,
But, you can see this in every application of AI, like driving. What generally happens is you take on board some assisted system, and to begin with, you're really hostile to it. And after a while, you start to go, oh, that's a bit good. Oh, I think I'll just leave that feature switched on. That sort of works for me. Yeah, I would have done that anyway. So you'll selectively enable or disable things. And to what extent, it's a competitive relationship. You put an AI into a tool that you use, you're in a competitive relationship with it. And with the people that put it there, I mean, look at, say, bubbling with Google or something like that, the whole filter problem. all these things that are supposed to assist end up really breaking shit, and people hate them, and they switch them off. Except on the occasions where they don't. In which case you then incorporate them into your model of the world. But what you want is you want to be able to have the control to switch it off. What you want is to be able to say, no, I'm switching to manual. Because if you couldn't do that, then, you know, when they tried to blow up Death Star at the end, if Luke had tried to I'm switching to manual control, it's like, no, I'm afraid you can't do that. Then the Empire would have won, wouldn't they?
That's very, very, very good. There's a lot of research about that exactly in our self-driving cars, where, you know, UX team of Audi came up with. I'm going to share with Ryan so you can share with the community. Very interesting article about the challenges in automating cars, and these guys came out with key principles. You know, they're about being able to see what the system is doing, what the system is aware of, what can you turn on and off. It's a bit like the auto release on the compressor. Do you want it on or off? You know, so we already have stuff like that. You know, I think those 4+1 principles are amazing. They're exactly what we need, you know, as engineers. Because another thing that we're trying to do, we do as engineers, and I'm really talking as a design, not as a sound engineer anymore, as a signal processing guy. We oversimplify what people do sometimes. So in our automation process, we bypass the complexity of, all you want is a ball around the pitch. So all I need is a two-dimensional model. But maybe that's a massive oversimplification of what they really do in their workflow. Whereas for other people, which have a simplified workflow, that might be, you know, all they need. So it's trying to get the best practices in, you know, as you know, researchers. You know, the more you know about sound engineering, the better it is probably. Without going back to the fader, of course.
Okay, yes, so because you've already had a question, Josh, so I'm going to go to the top.
Hi, so I had a question related to some of the topics about, I guess it's sort of a semi-political dimension of this intelligence notion, and if the panel has any comments on how to avoid encoding cultural biases and discrimination into these systems, and how we avoid homogenizing a culture by, you know, believing that we, you know, distilled the essence of something. You know, we've got examples where, you know, in tools like Twitter and Facebook, where there can actually be a reinforcing effect on really quite negative aspects of a culture. And I was just wondering if there's any comments related to these sort of ideas.
Yeah, you can't solve that from within inside the technology. It's a cultural question. I mean, you looked up Neil Postman or Matt McLuhan or any of those people that saw this with the development of media completely preempt that question. Sure, make it overt, make it an issue, make it a battle to be fought, but you can't fight it inside the technology. Technology does necessarily have this homogenizing, it's you know, a hegemonic quality to it. It takes on, it conquers, it spreads itself into all areas, and doing so, and you know, AIs in particular are going to just accelerate that. They're going to take models and they're going to universalize them. Maybe that tension will lead to more creativity. It sets up the necessary conditions for a paradigm shift.
I think the audio community is already massively culturally biased. You know, do you have multi-language mixing console, or is it just English?
Just English.
Yeah, so there you go. And I have an interesting story about it. So some people, some foreigner sound engineers, when I say foreigner, I mean not English, which is a bit biased, but anyway, you get the idea. They say, no, we don't want translation, because one of the reasons I have a job is because I'm the only one who can read English and mixing console, and that makes me a pro. I say, fair enough, you know. So and it's a male-biased community, isn't it? So sound audio engineers, so it's already very biased. I think probably technology will help, or I hope, because it's already very biased.
You just have to look at the panel down here to know that. So I'm going to maybe take one more final question, and then we'll start to wrap up. So do you want to, Brian, do you want to go?
Yeah, I guess I just wonder, somehow this turned into, again, there's the machines automating the process, or there's us getting to have control. And I just wanted to bring up that there is another way, which may also address cultural bias. And someone said, well, you can't expect to learn an instrument overnight. Why should you expect to learn this overnight? But I will say this, a trombone is not a piano. What a trombone can do and should do is very different from what a piano does, and we have both. And what I would like to say is maybe with some of the intelligent tools we're developing, people can have a completely different point of view about how one does mixing and mastering with completely different interfaces that open up new ranges of creativity and let people who think differently into the game. I don't think it has to be either the machines are taking over or we have our freedom. There's the whole how you can pan everything with the stage metaphor. There were people talking about doing good explorations of visual spaces so that design elements so that we break free of this channel strip metaphor. And the more we have intelligent systems that give us new angles and ways of thinking about the process, the more we're going to have new creative people enter into it and blow our minds with the music in it. So that wasn't a question, it was...
So we have time for another question because that was a statement. Do you want to finish, Josh? Or?
No, I had a niche question. I think that was a brilliant sort of, from beginning of today to...
that was kind of a mic drop moment, wasn't it?
Right, and I wanted to kind of add to that. I think, we're using automation and intelligence and somewhat kind of distancing the machine from the user in an erroneous way. I think really what we're talking about is making machines more intuitive, but without taking away the power of creativity, which has ultimately to come from the user, right? Because that's what we feel good doing is creating art, and then other people can actually take pleasure from it. So the idea here, I think what we're discussing is really how intuitive can we make some kind of interface, some kind of interaction with what we're trying to do, and at what levels. So obviously we talk about a very high layer which learns with you and actually kind of goes, ooh, that bass seems a bit resonant. Would you like to put a notch filter at 35 or 47 hertz? Yes, I would. And then you can start kind of opening up the bonnet and going down into other layers, and someone else who would like to completely subvert the system can actually go to the point where they break the code so that it creates a new, perhaps unwanted thing, right? So it's not so much about creating the distance. And I fully agree with your premise of what we need to do is we need to have machines that come closer to the user rather than further away. No doubt about that. So it's kind of creating intuition. Of course, there's got to be some kind of automation and intelligence in there, but the first premise is, can I approach this machine and start using it? The learning part, just to finish off, I guess is when you learn an instrument, you take great pleasure in going through the stages. So when you become a producer, a sound engineer, you will also take great pleasure in going through those stages. And perhaps we shouldn't take that away from, potential sound engineers of the future.
Okay, so I think I'm going to leave it there. If I apologise if anyone had a question and they never got to answer the question. Ask the question. There's going to be wine, free wine, pre-drinks, as Brett called it before, in the foyer just out here. So I'd encourage people to chat with these guys and try and continue the discussion. I'm going to pass you guys back over to someone. Do you want to make some final concluding remarks before we?
A very simple comment. So, thanks to Ryan, to the panelists, to all the presenters, particularly those in the poster sessions for very lively and interesting discussions and putting up with the heat. And thanks to all the volunteers. And special thanks to Brett, who actually did the vast majority of the work in making this happen. I did a bit less than any one of the volunteers. In fact, I did far more than everyone else. Thanks to you all.